Welcome to the Deep Dive.
Great to be here.
Today we're getting into the fundamentals of Nokia Data Center Fabric technology. We've basically got materials aimed at the Nokia Data Center Fabric Fundamentals exam, the 4A0-D01.
Right, the core concepts.
Yeah, think of this as a way to quickly get your head around the key ideas, SR Linux, fabric architecture, that kind of thing.
Sounds good.
Our mission, really, is just to pull out the most crucial bits from this exam prep, give you clarity without, drowning you in detail.
Absolutely. These materials are pretty focused. They give you a good look at the building blocks.
Okay, so let's dive in.
Yeah, it's interesting how all these pieces, the routing, management, automation, they all sort of fit together.
Definitely. Let's maybe start with a practice question. Get things rolling.
Okay.
All right. First one. Which protocol is typically used in SR Linux to distribute routing information within a data center fabric? Options are BGP, RIP, EIGRP, and STP.
Okay. Well, one of those definitely stands out for data centers.
Right.
And the answer is BGP.
BGP.
Now, BGP, the Border Gateway Protocol, people often think, internet routing between networks.
Just the big picture stuff.
But its role inside the data center fabric, well, that's where it's become really central in modern designs.
Exactly. It's not just external anymore. The material really hammers home BGP scalability.
Real critical.
Which you absolutely need in these huge data centers. Plus, it supports EVPN. We'll get to that for VXLAN overlays.
Right.
And you get that flexible policy-based routing. The notes even say it's ideal for modern leaf-spine architectures.
Yeah.
So the big idea is BGP's robustness makes it the choice for internal routing here.
Yeah.
You wouldn't really see RIP or EIGRP handling this kind of scale.
Precisely. I mean, just think about the sheer number of switches, the connections.
Yeah.
BGP handles that complexity, manages all those rights efficiently. It's just a much better fit than, say, older protocols that might struggle in these dense environments.
Okay.
So this internal BGP, it creates a really consistent and manageable routing layer across the whole fabric.
Makes sense. Okay, moving to question 2. This one's more about the architecture itself. What is the main function of the Nokia SR Linux's Yang-based model-driven architecture? Options. Simplifying firewalls, dynamic VLANs, supporting programmable automated configuration, or reducing hardware.
Right. The answer here is supporting programmable automated configuration.
Programmable and automated, okay.
And this really represents a fundamental shift in network management,
How so?
Well, moving away from configuring devices line by line manually.
Right, the old way.
Towards something more programmatic.
Automated.
Got it. So the explanation says this Yang architecture presents all the data config operational state in a really structured, standard way.
Exactly.
And that's the key, isn't it? Because once it's structured, automation tools, controllers, they can talk to the network using APIs like GNMI or netconf.
Right.
So it's all about making the network itself programmable,
Yeah.
enabling automation, like a machine-readable blueprint for the network. That's a good way to put it. Yang is like the common language.
Okay.
It describes the network state, what you want it to be, what it currently is, in a way machines understand.
Which means consistent automation, fewer errors.
Exactly. Boosts efficiency. It's part of that whole infrastructure as code idea, managing networks like software.
Interesting. Okay, third question deals with how we actually, manage these things day to day. In SR Linux, what's a primary advantage of using GNMI for network management?
GNMI.
Options. Faster packet forwarding, simpler cabling, real-time telemetry and configuration over gRPC, or better legacy support?
The answer there is C, real-time telemetry and configuration over gRPC.
GNMI, gRPC Network Management Interface. Sounds complex.
Sounds like alphabet soup, yeah. But it's actually a really big deal for network management.
Okay, break it down. The notes say it uses gRPC. That's the Google thing.
Right. gRPC is a modern framework, high performance.
Developed
by Google, yeah.
And the benefit is efficient, scalable communication between the switches and the management systems.
Exactly. But the really key part is the real-time telemetry.
Okay, real time. How's that different?
Well, traditionally, you'd poll devices, right? Ask them for info every few minutes.
Yeah, SNMP polling.
Which means delays. You don't always have the current picture. GNMI lets devices stream data continuously as things change.
Ah, so it's push, not pull.
Pretty much. You get a much more granular, up-to-the-second view of network health performance.
Which means faster troubleshooting, better visibility.
Right. Proactive monitoring becomes much more feasible. It's way more efficient than something like SNMP for getting data and pushing configs.
Got it. Okay, question 4. introduces another piece of the puzzle. What component in a Nokia Data Center Fabric is responsible for centralized service and network automation?
Centralized automation.
Options: SR Linux CLI, Fabric Services System, FSS, IPVRF, or Data Plane Processor.
Okay, the name kind of gives it away on this one. It's B, the Fabric Services System, or FSS.
FSS, Fabric Services System. Makes sense. The explanation calls it Nokia's centralized controller for SR Linux. So instead of managing switches one by one,
Right.
the FSS is the single point for network-wide automation service lifecycle management. It even mentions intent-based configuration.
Intent-based, yeah. You tell it what you want.
And it figures out how. The key phrase seems to be simplifying operations at scale.
Exactly that. Centralizing these functions makes managing these big dynamic fabrics much less complex.
Okay.
Operators define the high-level goals. FFS orchestrates it across the devices. Now, interestingly, the source material here, it includes this explanation about storage architecture in Azure Stack HCI.
Wait, what? Azure Stack? How does that relate to FSS?
It doesn't really, seems like maybe just a misplaced note in the exam prep material. Bit of a quirk.
Huh. Okay. That is kind of random. But the main point about FSS being the central automation brain for the fabric, that's clear.
Agreed. Yeah, sometimes study notes have these little detours, but the core role of FSS in streamlining things, that's the key takeaway.
Right. Okay, question 5. This shifts to logical separation within the network. Which of the following is a common reason to deploy EVPN in a data center fabric?
EVPN, important one.
Options: simplify CLI commands, avoid using subnets, enable Layer 2 and Layer 3 segmentation over VXLAN, or increase cabling distance.
The answer is C, enable Layer 2 and Layer 3 segmentation over VXLAN.
Okay, EVPN, Ethernet VPN.
Right. It's a really powerful technology in modern data centers.
So the explanation says it's often used with VXLAN to get both L2 and L3 segmentation.
Correct.
So you're basically creating isolated virtual networks on top of the physical gear. And it supports multi-tenancy, workload mobility, separating services, and it uses BGP, there it is again, for the control plane.
Yeah, BGP's back.
So it's about isolation and scalability. VXLAN does the tunneling, the data plane.
Right.
And EVPN is the smart control plane managing it all, learning agile addresses, etc.
Exactly. Think of EVPN creating these virtual walls inside the shared physical network, essential for like cloud providers with multiple tenants or big companies needing to isolate apps or departments.
For security, compliance.
All that. The combination EVPN control plane, VXLAN data plane, it's very scalable, very agile for segmentation. And guess what?
Let me guess. Another Azure reference.
Not Azure this time, but close. The notes here mention HPE ProLiant servers with Azure Stack HCI.
Seriously, HPE servers now. Okay, definitely some crossed wires in these explanations.
Seems like it.
But again, the core idea. EVPN enables segmentation, uses BGP, works with VXLAN. That's the important part.
Absolutely. Its real strength is extending Layer 2 over that Layer 3 VXLAN overlay, managed by scalable BGP. Much cleaner than, old school spanning tree for L2 extension.
Definitely sounds like it.
Yeah.
Okay, last question for this deep dive. Monitoring and troubleshooting. In SR Linux, what's the primary reason to use system logging with severity filtering?
Ah, logs. Everyone's favorite topic.
Options: encrypt logs, increase CPU performance, track only critical events, and reduce log noise, or bypass log rotation.
The answer is C. Track only critical events and reduce log noise.
Okay.
Anyone who's waded through network logs knows they can get noisy, very noisy.
Oh, absolutely. Trying to find the one important line in a sea of just stuff.
Exactly.
So the explanation makes sense. Severity filtering lets you focus on what matters. Critical errors, warnings, filter out the informational noise, the debug stuff.
Right.
Makes troubleshooting, monitoring way more efficient. You don't miss the important alerts in the flood.
Precisely. You categorize messages: emergency, alert, critical, error, warning, notice, info, debug, and tell the system, okay, only show me things above, say warning.
Focuses your attention.
Lets you prioritize, resolve the big issues quickly without distraction. And just to complete the set.
Go on.
The explanation here mentions high availability in Azure Stack HCI.
Of course it does.
Yeah.
Okay, well, there's a pattern. But the point about severity filtering, making logs manageable, stands. Essential feature.
Indeed. Good logging, good filtering, vital for a stable network.
Now,
Lots to explore.
definitely a dynamic field. Well, thanks for joining us for this deep dive.